Hello students. Today discussion is about the chapter chemical bonding. So students, to start the chapter, the discussion about chemical bonding. So first of all, how many elements do we have? We have 118 elements are there. Yes, sir, students. So like artificially synthesized, naturally found, altogether 118 elements. So all these elements, where can we find these elements? From the nature, right? From the naturally found from the nature. Okay. These elements, all these elements, do they exist independently or in the combined form? Answer this question. I'm asked, the question is, all these elements which are available in the nature, are they available independently or in the combined form? The answer is, all these elements, majority, they are available in the combined form only, not in the independent form. Sir, what is the proof? If they exist in the independent form, the whole universe, at least the planet Earth, is like how many types? 118 types only, na? Why all these possibilities? You know, why this wall, cement wall? Why this plastic? Why we exist? Why everything, all the possibilities? Why the trees? Everything. What is happening? All these things are happening because of chemical bonding. These atoms, they do not exist independently, but they exist in the combined form. Combined form means they chemically combine and they form chemical bonds and they produce a completely new substance. For example, hydrogen is an element, oxygen is an element. If hydrogen exists as hydrogen, if oxygen exists as oxygen, is there any possibility for the formation of water? No. They chemically combine and they synthesize new substance called as water, H2O. Yes, sir, no, students. So why do they combine? How do they combine? What are the factors influences for their combination? What are the types of chemical bonds are there? Everything we'll discuss in this video, in this chapter, chemical bonding. So to define chemical bonding, students, in general, when the force which holds two or more atoms together is called as chemical bond. Yes or no? All atoms are, the whole universe, like at least not the whole universe, the planet Earth, everything is made up of matter. Matter is made up of atoms. Do these atoms exist independently? No. There is some force acting on these atoms which exist like a molecules. So what is the force acting on these atoms to exist in a fixed ratios to form a molecule? That force is, we are calling it as chemical bonding. So how can you define a chemical bonding? The force which holds two or more atoms together is called as chemical bonding. So we have two types of chemical bonding, students. Mainly in this video we'll cover ionic bonding, covalent bonding and coordinate covalent bonding also. So to start the discussion with, why do atoms combine? Why do atoms form chemical compounds? The reason comes from noble gases. What is the group number for the noble gases? Noble gases are 18th group elements. Yes or no? What is their chemical reactivity? Are they chemically active? No. Why they are chemically inactive? They have 8 electrons in their valency shell or not? They have completely filled configurations or not? So they are chemically unreactive. Why? Because the S subshell and P subshell is completely filled. And now look at the remaining elements. Are the remaining elements configurations completely filled? Do they have completely filled S subshell? Do they have completely filled P subshell? No. You know why they are reacting, the remaining elements? They want to achieve the noble gas configuration. They want to get that 8 electrons in their valence shell. That is explained by a rule called as octet rule. Every element show tendency to get 8 electrons in its valence shell. That's why every element reacting, because in order to get that 8 electrons, then how does it get that 8 electrons? You know, some atoms, they lose their electrons to get that 8 electrons. Some atoms, they gain the electrons to achieve the octet configuration, and some atoms, they will share the electrons to achieve the noble gas configuration. Depends upon the configuration of that element. We have different criteria. Ultimately, the elements are reacting, the atoms are combining to form molecules. For what reason? The ultimate reason is in order to achieve noble gas configurations. Or why only noble gas configuration? That is giving the stability for the atoms. Or why it is giving stability? It is the completely filled configuration. Sir, why it is completely? All these are the reasons. Why? Because S and P energies are little bit low and they are closer to the nucleus. So if it is completely filled, that is giving a stability for the element. That's why in order to get that stability, in order to get that completely filled configurations, all these atoms, they lose electrons, they gain electrons, they share electrons. Ultimately, remember, chemical reactions, chemical bond formations takes place by which subatomic particle? by electrons only. So we have two types here, students. First type we have is ionic bond or electrovalent bond. So by definition or by the name itself, ionic bond means, like, what is ionic bond, students? The bond between the ions. Yes or no? Simple, in simple words, if you want to define ionic bond, what is ionic bond? The bond between the ions is called as an ionic bond. But which ions? Is it the bond between positive ion and positive ion? Do positive positive combine? No. Positive positive, they repel with each other. Is it a bond between negative and negative ion? Do negative negative combine? No. The negative negative also, they repel with each other. Then where is this bond exist? This is a bond. This is an attraction, electrostatic force of attraction between oppositely charged ions is called as ionic bond. That means there is an attraction between a positive ion and a negative ion. This attraction is called as ionic bonding. So, but students, answer, when an atom becomes a positive ion and when an atom becomes a negative ion? When an atom loses its electron, it becomes a positive ion. Sir, why it is losing? I already explained. In order to get octet configuration, it will loses its electron. And why an atom gains an electron? Same, in order to get the octet configuration. Octet means 8 noble gas configuration. So ultimately, after getting the noble gas configuration, are they stable, completely unreactive? No, they still carry the charges. In order to neutralize the charge, they show these attractions, opposite attractions, and these attractions between the opposite ions is called as ionic bonding. So to identify, students, ionic bonding, we have an experimental data, that is, if the electronegativities between the combining elements, if it is greater than 1.7, then definitely the bond is ionic. That means definitely an atom should have a capacity to lose electrons and opposite atom has a capacity to gain electrons, then only they will form ionic bonding. If both don't have capacities to lose or gain, then how do they form the bond? Then they can form the bond by sharing the electrons, that is covalent. We'll discuss that. Okay, students, what is the first condition in order to form the ionic bonding? The first condition is the combining element must have the capacity to lose and to gain. One atom should lose, other atom should gain, then only they form ionic bonding. This is explained in terms of electronegativity factor. Electronegativity should be greater than 1.7, then only we can expect this ionic bonding. So let us see few examples. This bond is also called as ionic or polar bond. So students, look at the bond formations of sodium sulfide. So sodium and sulfur. First of all, so students, what is the configuration of sodium? What is the atomic number of sodium? Atomic number of sodium is 11. What is its configuration? 1s2, 2s2, 2p6, 3s1, or by general numbers, what is the configuration? 2, 8, 1. Yes or no? Now, how many electrons are present in the valence shell? Only one electron. What I said, in order to get the stability of total, how many electrons should be there in the valence shell? 8 electrons. More, how many electrons it needs? More, 7. But students, is it easy to lose one electron or gaining 7 electrons? Which is better? Losing one electron or not? That's why sodium loses one electron. That's why some elements loses electrons, because of their configurations. So here sodium loses how many electron? 1 electron. Clear? Now sodium atom becomes sodium ion, which is Na plus ion. Right, students? Got the clarity? Now sulfur. So what is the configuration of sulfur, students? Configuration, atomic number of sulfur is 16. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p4. That means how many electrons are there in the valence shell? There are 6 electrons are there in the valence shell. 6 electrons means more, how many it needs? In order to achieve octet configuration, more 2. Now answer. Gaining 2 is better or losing 6 is better? Now this time gaining is better. Gaining 2 is better. Sir, no. So that's why sulfur is gaining 2 electrons. Sir, but you said only one sodium, na? So that's why it can gain one more electron from one more sodium. That's why 2 sodiums are represented on the given example. You can see one sodium giving 1 electron, another sodium atom giving another electron. This is a Lewis dot representation, students. These stars indicates the valence electrons. Even the dots also indicates the valence electrons of this combining element. So sodium loses some electrons. Sodium is not losing 2 electrons. Sodium is losing 1 electron only. And one more sodium losing 1 electron. Both the electrons are gained by 1 sulfur. Now sodium achieved the noble gas configuration or not? Right? Why? Because it gets 1s2, 2s2, 2p6, neon's configuration. After gaining the 2 electrons, even sulfur also achieves the noble gas configuration or not? Right? Argon's configuration. So that's why, that's how they get the stability. After getting the stability, still they have a charge. Sodium after losing electron, what is the charge it will get? +1 charge. And sodium after gaining 2 electrons, what is the charge it will get, students? -2 will charge. Then how they can be neutralized? How they can be neutralized? They should combine in what ratio? They will combine in 2:1 ratio. That means the charge on sodium is -2. How -2 can be neutralized? If there is a +2, right? But on each sodium there is +1 only. So how many sodiums it needs to combine with? 2 sodiums. +1 +1, how much? +2. +2 -2, how much? 0. Got the clarity, students? So 2 sodiums can neutralize one sulfur atom. So that's how it exists in the nature. Pure sodium, does it exist in the nature? No. Pure sulfur? No. Then how do they exist? In the combined form only. Pure sulfur means S8 molecules are there. I am asking in terms of ionic bonding. So students, next some other examples you can see. Potassium chloride. Potassium, what's the configuration? 2, 8, 8, 1. Right? 4s1 configuration. So it contains how many electrons in the valence shell? It contains only 1 electron, students. So what is the criteria for potassium? To lose electrons or to gain electrons? It is better to lose 1 electron, right? If it loses this electron, now it readily achieves noble gas configuration or not. So that's why potassium is losing. Chlorine, atomic number 17. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p5, or the general 2, 8, 7. Already 7 electrons are there in the valence shell. More, how many electrons it needs? More, 1 electron only. So that's why it needs 1 electron. Potassium want to lose 1 electron. So the electron of potassium was lost and it is gained by the chlorine. Students, got the clarity? Now after this shifting, potassium becomes potassium ion and chlorine becomes chloride ion. Got the clarity? Now K plus and Cl minus, they need to combine in what ratio in order to form a neutral compound, students? 1:1 ratio. That's why KCl exists. Now KCl molecule, it's a stable molecule as well as it's a neutral molecule. Potassium chloride. Got the clarity, students? And same with calcium oxide. And the same with calcium oxide. Calcium atomic number is 20, right, students? Its configuration is how much? 4s2 or 2, 8, 8, 2. 2 electrons are there. Now answer, it is better to lose 2 electrons or gain 6 electrons. Losing 2. Metals always loses electrons, remember. There are some exceptions are there. And oxygen configuration is 2s2, 2p4. 6 electrons are there. It is better to gain 2 electrons, right? So the calcium is losing 2 electrons. Oxygen is gaining 2 electrons. Now calcium get octet configuration. Oxygen also gets octet configuration or not? Now, but what is the charge calcium gets after losing 2 electrons? The charge will be +2. And what is the charge oxygen gets after gaining 2 electrons? The charge will be -2. +2, -2. In what ratio they need to combine in order to form a neutral compound? 1:1 ratio. Got the clarity? So what is the formula between calcium and oxygen? The formula is CaO, calcium oxide. Is it an ionic compound or molecular compound? This is an ionic compound. Why? Because calcium is losing electrons and oxygen is gaining electrons. Right, next, covalent bonding. First of all, to start the discussion with definition, first of all we need to consider the criteria, the condition for the formation of covalent bond. You already know when ionic bond forms. Yes, sir, students, when the combining elements have a capacity to lose or gain. Why they are losing or gaining? In order to get octet configuration, noble gas configuration, right? Then they form ionic bonding. But if the combining elements, if they don't have this capacity to lose or to gain, then how do they get the stability? You know how? By sharing the electrons. What is sharing? I will show you in the example, students. So the bond forms by sharing the electrons is called as covalent bonding or covalent bond, and the compounds are called as covalent compounds or molecular compounds. Got the clarity, students? The definition, the bond forms by sharing. And what is the condition? When do they share the electrons? They share the electrons when the combining capacities of the combining elements are low. Combining capacities means when the element doesn't have capacity to lose electrons or if it doesn't have the capacity to gain electrons. I already gave you one experimental point, that is if the electronegative difference between the combining elements, if it is less than 1.7, that means they don't have that much capacity, then they will share the electrons. If it is exactly 1.7, also almost they form ionic compound only and also have some covalent character. More than 1.7 ionic, less than 1.7 covalent, remember. So one example also given here, students, formation of hydrogen molecule. What is the formula of hydrogen gas? The formula of hydrogen gas is H2. H2 means how many hydrogen atoms are there in this molecule? 2 hydrogens, right? What is the configuration of hydrogen? Atomic number is 1. The configuration is 1s1. Only 1 electron is there. More, how many electrons it needs? More 1 electron or not? Why? Because in order to achieve helium configuration, 1s2. Now, can it gain that one electron from the other hydrogen? No. Why? Why that hydrogen will give? That hydrogen also belongs to the same element, right, students? Both have same capacity, right? How one hydrogen will lose and one hydrogen will gain? Do they have different capacities? No. Then what will happen? They will share the electrons. If they share the electrons, sharing the electrons means previously the hydrogen atom contains one electron, right? You can see in the image. And this hydrogen also gets one electron. This star and dot were represented just to give the difference between that hydrogen atom and this hydrogen atom. Now, after circling, this is what the circling is. After circling, now this electron and this electron both are influenced by first hydrogen nucleus. That means 2 electrons means what's the configuration? Helium configuration. Now again in this dot, this electron and this electron also influenced by this hydrogen atom. That means this also gets helium configuration or not? Ultimately, both the electrons they share between 2 atoms. Both the electrons are influenced by the nucleus of both the atoms. That is what the sharing is. Understood? Exactly practically how do they share? We have a theory called as valency bond theory. In the next video, we will discuss about that theory. So, in between both the hydrogen students, how many electrons do they share? They share one pair of electrons. Yes or no? 2 electrons means one pair, right? If one pair of electrons, you know how to represent that bond? With a line, just one line. That line indicates one single covalent bonding. One single covalent bonding. That single covalent bond is made up of how many electrons? 2 electrons. One electron belongs to one hydrogen and other electron belongs to other hydrogen before the bonding. But after the bonding, both electrons belong to both the hydrogens. 1:2 configuration. Got the clarity, students? Like that, atoms can form double bonds. Even atom can also form triple bonds also between the 2 atoms. 4 bonds are not possible. The reasons we'll discuss in the valency bond theory. Why? Because the bondings becomes more weak and weak, so they do not form the 4th bond. So look at these examples. All these examples comes under covalent bonding only. Look at this methane example. Carbon bonds with 4 hydrogens. Carbon's valency is 4. So 4 dots are represented. Hydrogen valency is 1. It has only 1 electron. Now students, now these 4 electrons bonds with 4 other hydrogens, right? Now each hydrogen, look at how many dots are there. Look at the circle. Each hydrogen gets 2 electrons, helium configuration. This hydrogen, helium configuration, helium. Now look at the electrons which are surrounding the carbon. How many electrons are there? How many dots are there? 8. 8 means octet configuration or not? All this happens in the valency shell, students. Octet configuration or not? So every atom gets octet configuration from carbon and hydrogens gets duplet configuration. 2 electron configuration is called as helium configuration is called as duplet configuration. Now listen here. Between carbon and the left hydrogen, how many electrons are there? How many electrons they share? 2 electrons, one pair of electrons, so 1 bond. Between this carbon and the top hydrogen, how many electrons? 1 pair, so 1 bond, 1 bond, 1 bond. Total how many bonds are there? 4 bonds are there. Sir, but you said 4 bonds are not possible. Remember students, 4 bonds are not possible between the 2 atoms. Is it all the 4 bonds are present between 2 atoms? No, there are total 5 atoms are there. This is not the quadruple bond. These are 4 single bonds. You can see between any 2 atoms, how many bonds are there? Only 1 bond. These are 4 single bonds. Got the clarity? And hydrogen chloride example also. Hydrogen, students, how many dots? 1 dot. Its valence electron is 1. Chlorine, how many dots? 7 dots. Valence electrons are 7. So how many? Hydrogen needs 1 electron. Chlorine also needs 1 electron. Sir, why they are not losing and gaining? Why? Because they don't have that capacity. That electronegative difference is not there. Then they will share. How many electrons they will share? The same number. How much they need? They will share the same number. And remember, equal sharing of electrons takes place, students. Equal sharing means if one atom is sharing 1 electron, other atom also shares 1 electron only. If one atom is sharing 2 electrons, opposite atom also shares 2 electrons only. Equal sharing of electrons. Here, hydrogen is sharing 1 electron. Chlorine is sharing 1 electron. You can see the into and the dot, star and the dot, just to give the difference between hydrogen electron, chlorine electron. Ultimately, both the electrons are getting shared between hydrogen and chlorine. Now, hydrogen gets helium configuration and chlorine gets argon's configuration. Got the clarity, students? Both are getting stabilized. Understood? Do they get any charge? No, they won't get any charge in the covalent compounds. Why? Because there is no losing happening, there is no gaining, nothing is happening here. So, how many bonds are there between hydrogen and chlorine? They share 1 pair of electrons, so 1 bond. Look at the representation, H bond Cl. A bond is made up of 2 electrons, and in these 2 electrons, 1 electron belongs to 1 atom, other electron belong to the other atom. Got the clarity? So, in covalent bond, students, we have two types of covalent bonds. One is called as polar covalent bond, other one is called as non-polar covalent bond. First of all, polar covalent bond. Polar covalent compound means, the same example, look at HCl. HCl, yes or no? In these two elements, students, in these two elements, which element is highly electronegative? That means, which element has more capacity to gain electron? First of all, do they have same capacity? No, they are different elements. Definitely one has high capacity. Which is that high capacity element? Chlorine. Left to right electronegativity increases. Sir, but you are saying it is highly electronegative, but it is not gaining. Why? Because why it is not gaining? Electronegative difference, yes or no, between the combining elements. So that's why they are sharing. Even after sharing also, one is highly electronegative or not comparatively, it shows its electronegative character. You know how does it shows? They share how many pairs of electrons? One pair of electron, right? Where does this one pair of electron exist? Exactly in between the two atoms, or this one pair of electron exist or any side of the atom? You know how it happens? This pair of electrons, the bonding pair of electrons, are more closer towards the chlorine side. Chlorine is not gaining, hydrogen is not losing. Already they shared one pair of electrons, but this pair of electrons are more towards the chlorine side. Sir, why they are more going towards chlorine? Because chlorine has higher electronegative character. What is electronegative character? Tendency to attract the electrons, which is more for chlorine. Got the clarity, students? So what happens after this? What is the charge on electrons? Negative. If they are more closer towards the chlorine side, chlorine gets a partial negative charge and hydrogen gets a partial positive charge. Why? Because they are moving away from the hydrogen. Is hydrogen losing? Is it a complete positive? No, partial only. Hydrogen is not losing, chlorine is not gaining. Simply the electron cloud is shifted more towards the chlorine side because of the electronegative character. And having these partial positive charges and negative charges is defined as polar covalent compound. What is the name, students? Polarity. Partial positive and negative charge is called as polarity. Then what is non-polar covalent compound? Non-polar covalent compound means these partial and positive and negative charges, they do not exist. For which type of molecules they do not exist? You know, for the molecules which are made up of same elements. For example, hydrogen gas example we discussed. Yes or no? Hydrogen gas, students, H2, two hydrogens are there. They share one electron each. Now these pair of electrons, where they are present, exactly in between or towards any side of the hydrogen? These pair of electrons are present exactly in between both the hydrogen, students. Exactly in between both the hydrogens. Sir, why? Why? Because both are same elements, na? Both capacities are same, right? Why they shift towards any side? Now if they are not shifting, now what do they develop any charges, partial positive or negative charges? No. If they are not developing any partial positive or negative charges, that is a non-polar covalent. It is covalent only, but non-polar. Non-polar means no partial positive and negative charges. Got the clarity, students, between polar and non-polar? Look at some of the examples: O2, Cl2, N2 and fluorine gas. All comes under non-polar covalent compounds, and HCl, H2O, ammonia, and comes under polar covalent compounds. In HCl, which is highly electronegative? Chlorine. In H2O, which is highly electronegative element? Oxygen. And in ammonia, which is highly electronegative element? Nitrogen gets partial negative charge. So all these molecules are covalent compounds, but they comes under polar covalent compounds. You know, atoms gets displaced more towards the fluorine. In HF molecule, the electron cloud shifted more towards the fluorine side. So that is polar and non-polar, students. Next, the last type of chemical bonding in this video, which is coordinate covalent bond. What's the name? Coordinate covalent bond only. It's not coordinate ionic bond. So you already know the idea. Means here also sharing takes place, right? That's why it is named as covalent bond. This bond is also called as dative bond, students. And the reason behind this name, coordinate covalent bond, what is really happening? Sharing only. But how do they share the electrons? You know, what is covalent bonding? In covalent bonding, how the electrons are getting shared? Equal sharing of electrons, right? That means if one atom gives one electron, other atom also gives one electron. But in coordinate covalent bonding, unequal sharing takes place. Unequal sharing means one atom or one species provides the electron, other species takes the electron. That means one particle acts like a donor, another particle acts like an acceptor. This unequal sharing of electrons is called as coordinate covalent bond. A covalent bond in which both electrons, a covalent bond in which both the electrons of the shared pair are contributed by one of the two atoms is called as coordinate covalent bond. What are the conditions? When does this happen? Ultimately, it is sharing only. They are not losing or gaining, but unequal sharing. You know, what are the conditions for this formation? In both of these combining element, one element or one component should have a lone pair electrons. What are lone pairs? Non-bonding electron pairs are called as lone pairs, right? And other component should have empty orbital. Empty orbital means orbital which no electrons in the valence shell. Now, this empty orbital can accommodate two electrons or not. So, this lone pair of electrons can fit in this empty orbital. That is what coordinate covalent bond. Is this atom losing? No. Donating means it's not losing. Is this atom gaining? No, it's not gaining. Still both the electrons are influenced by both the atoms. That's why it is called as coordinate covalent, not coordinate ionic. It's no losing happens, no gaining happens. But unequal. One is giving, one is taking. Giving means not completely, no, gone. Still both those two electrons are influenced by the donor and both the electrons are influenced by the acceptor also. Got the clarity? And look at this image here. A having these two electrons which are influenced by the element B. Now these two electrons are influenced by both A and B, and these two electrons are coming from where? A. Here A acts as a donor and B acts as an acceptor. Got the clarity, students? Next. So some of the examples for the formations of this coordinate covalent bond: ammonia and boron trifluoride. Ammonia, students, you can see ammonia valency is 3, but there are one lone pair of electrons in ammonia. You can see this lone pair of electrons. And boron configuration is 2s to 2p1, and this 2s electron excites to the middle orbital of 2p, and there is one empty orbital in the 2p subshell of boron, and this empty orbital can accommodate two electrons, and you know that's how they can form this conjugate between ammonia and boron trifluoride, and this is how the coordinate covalent bond is indicated by like an arrow. Got the clarity? What are the conditions for the formation? One should have empty orbital, other should have lone pair. Which way acts as a donor? Empty orbital component or lone pair component? Lone pair component acts like a donor, empty orbital component species acts like an acceptor. Next, formation of ammonium ion. Same ammonia example, but in terms of H plus ion. Ammonia is NH3 having a lone pair of electron. Just now we discussed in the previous example also. H plus, what is the configuration of H plus? No configuration, 1 has 0, no electrons are there, na students? That means empty orbital, right? So this H plus ion directly attacks this lone pair of electron. That means here they are sharing only. Both the electrons are influenced by nitrogen and hydrogen only, students. Here nitrogen is not losing electrons, hydrogen is not gaining electrons. Both the electrons are influenced by both atoms. They are sharing only. But is this equal sharing? Here hydrogen, is it providing any electrons? No. This is unequal sharing. Only nitrogen is providing, hydrogen is taking. That's why this bonding is called as coordinate covalent bond, and the whole particle get a positive charge. Why? Because H plus ion is bonding here. Got the clarity? This ion is called as ammonium ion. So unequal sharing of electrons takes place in the case of coordinate covalent compound. So look at some of the characteristics of coordinate covalent compound. So coordinate covalent compound is generally, its properties are in between ionic and covalent. It is little bit more than covalent, less than ionic, like that. So look at the first point. Coordinate compounds exist as gases, liquids and solids under the ordinary condition. That means in all the three physical states. The melting and boiling points of the coordinate compounds are higher than those of covalent compounds, and but lower than those of ionic substance. Ionic compounds have very high melting and boiling points. So these coordinate compounds are in between ionic and covalent, and these are less soluble in polar solvents like water, but readily soluble in non-polar solvents like benzene and carbon tetrachloride, CCl4. They are very less soluble in polar solvents. Polar solvent means, I said, no students, polar covalent compounds. So because of this covalent nature, they are more readily soluble in non-polar solvents like organic solvents like benzene, ether, kerosene, CCl4, carbon tetrachloride. So they have more covalent nature rather than ionic nature. So these are some of the main points of coordinate covalent bond. So students, in this video we discussed about what is the significance behind the bond formation, and what are the applications in the bond formations, as well as types of chemical bonds, ionic covalent, coordinate covalent, and examples, and what are the conditions for these bond formations, everything clearly with all the reasons we discussed. So that's all for today in this video, students, and we'll meet you in the next class in another video. Thank you, students.